right, so here we go. Let's, I'm going to quickly go through the three properties. Now, these properties, you know, they're not severely important. I mean, but you do need to know them, and they can be helpful to you when you're simplifying. You do need to know how to expand and condense. That's something that we do in calculus. We don't do a whole lot of it, but we do it. So let's go through with the properties. There's the product, the quotient, and the power property. Okay, and it's exactly what it says. The product property is taking the log of a product and expanding it into the sum of two logs. Those two things are equal to each other. And the same, and in the opposite direction as well. If you are adding two logs together with the same base, you can condense it into the log of the product of each of their arguments. Now, it's not the log of u times the log of v, it's the log of u times v. Okay, so you can go both ways. And then quotient is just what it says. If you have the log of a quotient, that is equal to the difference of two logs. So if you have the log of 10 minus the log of y, you can change that to the log of 10 divided by y. I'm going to write down one thing you should not do. Do not tell me it's the log of 10 divided by the log of y. Okay, that would not make sense, and that's a common mistake that I see. It's not the log of the first. It's not the log divided by the log. It's the log of the first divided by the second argument here. So don't do this, because that's like telling me that 10 minus 6 is the same thing as 10 divided by 6, which is just not true. Okay? So let's just, and then there's the power property. If the log of the exponent can come out in the front, or if you have an exponent or a number in front, you can move it up to, if you have a coefficient in front, you can move it up to the exponent. So again, the 12 here can come out in front, or the 12 in front can come up there. So those are the three properties. So one of the things that you will be asked to do is expand. Expand means no products, no quotients, no exponents. Expand completely. So let's take a look at those, okay? All right, so this is the log of a quotient. The log of a quotient is equal to the difference of the log of the top minus the log of the bottom. So that's the one that we're going to use right now. So, and again, if I go too fast, I will post this so you can go back. So log of 3x base b minus the log of z, that's my crazy z right there, so it doesn't look like a 2, base b. Okay? So the one thing that people will miss is the product. I said no product, no quotients, and no exponents. But what people miss is this 3x right here. This is a product. This is 3 times x. So you need to take the log of the first plus the log of the second, which is the x. I'm taking a product and I'm making it the sum of two logs using, that's the product property, minus the log of z base b. So this is not a product, there's no exponents, not a product, no exponents, not a product, no exponents. This is completely expanded. Okay? So let's take a look at this one right here. Okay, now some of you, and again, I don't know when you did it. I don't know if you did it last year as freshmen or if you did it in Algebra 1, but some of you are having problems with changing roots to rational exponents. So for those of you who don't remember doing this, if you take the 5th root of x squared y, that's the same thing as raising it to the 1/5 power. So square root is 1/2 power, cube root is 1/3 power, Fifth root is 1/5 power. You get the idea. Okay? So all of this raised to the 1/5 power, what I'm going to do first is I'm going to apply my algebra properties. And I'm going to keep, again, all of this has to be in parentheses because you're raising the whole thing to the 1/5 power. Without the parentheses, it's a completely different problem. So by doing that, another way of looking at it is the fifth root of x squared. The fifth root of x squared is x to the 2/5. That's, again, changing it from radical form to rational exponent form, or power of a power you multiply. The fifth root of y, and I can do it individually because it's a product, so you're allowed to split it up. The fifth root of y is y to the 1/5. Or, if you look over here, y to the 1/5. Power of a power property. This is a 1 here. So either way you look at it, this is the problem that we're dealing with in rational exponent form. Okay, so I said no exponents and no products or quotients. Well, this goes with the x, and this 1/5 goes with the y. I can't just move them out in front of this log unless they're independent by themselves. So I'm going to deal with this product. Again, you need to recognize that even though there's not a multiplication sign there, that is a product. So I'm going to use the product rule, and I'm going to change it to the log of a sum. Oops, I dropped my base. Don't drop your base. Keep the base the same. So I took the log of a product and I changed it to the sum of two logs using, that's the product property. Okay, so again, expand completely, no products, no quotients, no exponents. Now that this goes with this x and it has a log in the front, I can now move that using my exponent property. And now you have completely expanded your logarithm. Okay? All right, next one. This is the natural log of all of this. So sometimes putting everything in parentheses might be helpful. Okay? So anytime you have radicals, the first thing that I would recommend, and again, these are things that you should write down and memorize. There's a lot of memorization involved in this chapter. So the more you write down, the more you memorize, the easier it will be. My suggestion is anytime you have radical form, you change it to rational exponent form. So square root is a 1/2 power. So now, no products, no quotients, no exponents. So deal with the products and quotients first. I have 4xyz. Again, this is 4 times x times y times z. So don't forget, 4x is a product. So we need to use the product rule. So we're going to take the natural log of 4 plus the natural log of x plus the natural log of y plus the natural log, I don't know why I changed my L there, but natural log, natural log, natural log, natural log of z to the 1/2. The natural log of a product is equivalent to the natural log of the sums. Okay, I should rephrase that. The sums of the natural logs. Do not say it's the natural log of 4 plus x plus y plus z. It's the natural log of 4 plus the natural log of x plus the natural log of y plus the natural log of z. And last but not least, no exponents. So again, ln is a log, so you can use a log property, and that is completely expanded. Okay, now we're going to go to doing the other way. We're going to condense. And the first thing that you need to know is in order to condense, okay, in order to condense, the lead coefficients here have to be a 1. That's the most important thing to remember before condensing. Okay, so this 3, we have to get rid of that before we can condense. We have to get rid of the 4 before we can condense. Well, we have a power property that allows us to move that to the exponent. So that gives us the log of x to the 3rd plus the log of 3 minus the log of y to the 4th. So that is the exponent, that's the power property. If it's in front of the log, you can move it up to the argument of that log. Okay, so a sum of logs is the same thing as the product of the argument. So the product of this and the product of this, which is 3x cubed. And then if we subtract a log, that's equal to the log of this being the denominator, the log of a quotient. So we can just put that here. And again, I like to put parentheses. That is completely condensed. Okay, so moving on to the next one. The 2 has to get moved up here. The 3 has to get moved up to the 2, and the 2 has to get moved up to the 4 in order to use the other properties. So we have the log minus the log. So that's the log of a quotient. So we're going to take this argument here, which is x squared, and we're going to divide it by this argument here, which is 2 cubed, or 8. And then we have plus the log of 4 squared. So that is the product, because it's a plus, because we're adding a log, we multiply by the argument. And a 4 squared is 16. So your final answer for this one is the log of 2x squared. Oops, base 5. Don't leave off your base. Okay, and then the last one, 1/2 goes to the 9, 3 goes to the quantity of 2x, and 2 goes to the quantity of y squared. So this is a sum of logs. So that's the log of their product. So the natural log of the product, the argument here is 9 to the 1/2. That's 3. 9 to the 1/2 is 3. 2x, the quantity cubed, is 8x cubed. Y squared to the 2nd is y to the 4th. So your final answer condensed is the ln of 24x cubed y to the 4th. So this would be the condensed version of this. So that's what you're going to be asked to do. You're going to be asked to expand and condense. Expand completely and condense. Now, these properties can be useful in helping you evaluate log expressions without a calculator, which is what you did yesterday. You evaluated without a calculator. But these properties allow you to do it in a different way. Not in whichever way you pick is completely up to you, as long as you show your work. So let me show you, we could do this, we could do all of these problems except this one. Actually, no, we could do this one. We could do all of these problems without using the properties. There's no doubt about it. But let me show you how using the properties will help you, okay? So just an alternative way to evaluate these. I'm going to change this to the 1/3. I'm going to move the 1/3 out in the front. Now what you guys should know that when these are the same, the log of 5 base 5, that's just equal to 1. When it's saying a log is an exponent to which you raise the base. That's a little too high for me, so I'm going to move that down a little bit. What is the exponent to which you raise 5 to get 5? It's 1. So anytime these are the same, the log of that will always be 1. So 1/3 times 1, the answer is 1/3. Okay? So now on this one, we could do this by itself, and we could do this by itself, the way you did it before, and then subtract your answers. Or you could use your quotient property. The natural log of, again, we're going to take the first argument, and we're going to divide it by the second argument. Don't divide the natural log divided by the natural log. It's the argument divided by the argument. And that gives you ln of e to the 4th if you use your algebra properties. And then, again, because this is an exponent, we can move that exponent out in front. And here we go again. The natural log of e is equal to what? This base right here is e. So when these are the same, e to the what power gives you e? 1. So this is 4 times 1, or just 4. Okay. All right. Now, we did these before by changing it to exponential form and making the bases the same and solving. That would work. Or I can use a property. Now, why would I want to change that to 4 times 2? Because 4 times 2 is 8 for 1. And again, I like it when these are the same because I know that that's just equal to 1. So I change this to a product. And then I can use my product property, which is saying the log of the first plus the log of the second. I can expand it. So again, this right here, when these are the same, you should know that that's equal to 1. But again, these aren't the same. So this is a little tricky here. I like them when they are the same. But obviously, log of 2 base 4 is not the same as log of 4 base 4. However, I can rewrite this as 4 to the 1/2. Because, again, you should know that that means square root. So now that these are the same, I like that. And I also can use the power property here. And again, this is equal to 1. So it's 1 plus 1/2. And the answer is 3/2. Now, I'm not sure that I would do the problem that way. I would probably do it the way that we did it before. And I would say 4 to the what power equals 8. Well, that's 2 to the second, and that's 2 to the third. So 2x must be equal to 3, x must be equal to 3/2. That's the way we did it before. It doesn't matter which way you do it. Okay? There's multiple ways to do evaluating expressions, and there's multiple ways to solve equations, and that's where people get confused. I just want to know one way to do it. So pick which way makes the most sense to you. As long as you can get the answers, you'll be fine. Okay? So that is the end of the notes. And we are out of time. So